Well, hello there. We're going to have a look at the rules, determining the rules for exponential and log functions. And it's very interesting, so let's make a start and see if we can make some really good progress today. Now, here's our first cab off the rank. We've got the rule for a function of the graph is of the form y equals a e to the x plus b. Find the values of a and b, and we've got our nice little specimen here to help us along. So, what do you think, guys? If you have a look at that, what what strikes you first, apart from, how am I going to do this? Well, look, how many unknowns have we got here? We've got this one, we've got this one, and we've got 2 points. So I think probably the best thing to do is to substitute those 2 points into the equation, and we'll get 2 equations in 2 unknowns. That would be my strategy. What do you think? So let's try that and see how we go. So we substitute 0 and 6 in as our first point, and we get this equation here, and we just clean that up a bit and we get a plus b equals 6. Very nice. Now we substitute the other point in, that's the 3 and 22, which you see over here. And what happens then? You substitute that in, you get that. Now, so let's go. From equation 1 is probably easier than trying to substitute something from equation 2, because that looks a bit yucky with this funny looking thing here. It's a bit scary, isn't it? So you just, I would do this. I'd say, okay, b is nice to substitute for, so let me call b from this equation equals 6 minus a, and we'll substitute that into here. It's probably the least painful way to do it. Substitute into 2, and what do we get? We get, okay, that's what we get. Now, that's interesting. So look, we're looking for a, so here's an a term here and here's an a term there. So why don't we group those terms together and get all the rest of it over the other side of the equation? Oh, that's nice, isn't it? Okay, so therefore, look, it's looking easy now, very easy. So therefore a would be 16 over e cubed minus 1. Now we've got to substitute back for a, and I suggest we use this equation here. Wouldn't you? I think so. So we substitute that into there, and what's going to happen? We get that, and therefore we get that. Good, and that equals, putting it over the same lowest common thingo, we get that, yes, and then we simplify a little bit there because these 2 terms can be consolidated, and we get that. Okay, so that looks like what b is. So therefore, summarising our answer, there's a and there's b, and it fills us with glee. Of course it does. Yes? Are you feeling good? Great. Okay, let's do another one. Now we're on a roll. This is a loggy one now. Good heavens. Not so bad, not so bad. Logs a lot of people find logs very scary, but they're not really all that scary once you get a little bit familiar with them. They're very nice little functions. So we've got the rule for the function of the graph shown is of the form y equals a times log base e of x plus b. We have to find the values of a and b. Well, again, same old, same old. We've got 2 points here. We can substitute in, can't we? I think so. Actually, I think I know what b is already, but we won't preempt things. All right. So we'll see how we go. Y equals a log base e of x plus b. Let's substitute 5 and 0 in, and what do we get now doing that? We get that. That can be equation 1. Now we'll do substituting the other point in, and we get this for equation 2. Okay, now here's something that you might not have tried before. How are we going to unravel this to work out what a and b are? Well, b is stuck in here with all this stuff. That doesn't look too promising, does it? So it's probably better for us to work out a, you might say, but I would differ from you on that one, because look, there's a nice little trick you've probably never seen before. You'd probably you'd probably say, well, therefore from this equation here, maybe you could say that a is 1 over log base e of a plus b, and then try and go from there. But I've got a new little trick for your mathematical toolkit for you. I'm going to divide equation 1 by equation 2. Okay, equation 1 by equation 2. Now what happens when I do that? You watch. look, see the A's, so this side, the left-hand side is 0 over 1, or still 0. This over this whole thing, just gets us log of 5 plus b over the log of 8 plus b. So that's fascinating. And this 0 helps us enormously because, look, when we multiply both sides by this beastie down here, you still get a 0. You see what I mean? Now, what do we do now? Okay, what do we do now? Can you think? Well, I would say, therefore, 5 plus b must be e to the 0, because that's the rearrangement of this equation here into this form here, okay? Yes, do you get that? Because this is the base, this is the index, this is the number. So this base to this index gets us that number. And everybody knows what e to the 0 is. You know, don't you? Of course you do. That's 1. Yes? Okay, so therefore we've got it down to a most agreeable form where we're saying 5 plus b equals 1, therefore what's b? Minus 4. Yes? Now, we can substitute for b as minus 4 back into either one of those equations. I think I'll choose this one. Would you agree? Yeah, it's probably more productive than that one, because if we put b as minus 4 into that one, we'll just get a log of 1, a times log of 1, and log of 1 is 0 anyway, so that doesn't really get us a too easily, does it? So you've got to think a little bit about these. These loggy creatures make you think a bit more, but they're still friendly enough. So let's substitute b is minus 4 into equation 2, okay? So what do we get? We get 1 equals a times log of 4, and therefore what's a? Yes, it's just 1 over log of 4 base e. So there it is, and just summarising that over there, and what was b again? B was minus 4. Yeah. Okay, how do you like that? Pretty good, hey? So now we're on a roll, we'll try another one. This time we've got, given that y equals a e to the bt, and y is 6 when t is 1, and y is 8 when t is 2, find the values of b and a. Well, look, guys, just the same old, just two simultaneous equations, and off we go, I think. Same procedure. So, therefore, y equals a e to the bt, that's our equation. We'll substitute y equals 6 and t equals 1, and what do we get? We get that equation, okay? Now we'll do the same thing with y equals 8 and t equals 2. Substituting into this original equation up here, what do we get? We get that. Okay, we've got two equations, two unknowns. Now, again, I'm going to pull this new trick. I'm going to pull that rabbit out of my hat, and I'm going to divide again. I'm going to divide equation 2 by equation 1, right? Equation doesn't really matter which way you do it, but I think it's going to come out easier because I've got e to the 2b here, and I'm going to be dividing by e to the b, so I won't have any negative exponents if I do it that way. Just thinking ahead a little bit. So dividing 2 by 1, I'm going to get 8 over 6 equals e to the 2b over e to the b, which, as you know from your index laws, you can re-express. That just cancels down. 4 over 3, that's going to be e to the b. Right? Now, do you know what to do now? You've got to get b. B's in the exponent, right? What do you do? Well, when you've got b in the exponent or anything in the exponent, you have to solve for it. You have to take the log of both sides. That's what you have to do. So therefore, we know that b is going to be log of 4 over 3 with a base of e. Now, if you don't know how to do that, you better ask somebody, because that's pretty fundamental. Flipping between this form and this form is absolutely basic, absolutely essential knowledge if you want to master logs and be able to deal with them and make them friendly. Okay? Alright, now we've got b, so we need a, don't we? Yes, alright, so let's substitute for b in equation 1, should do it. What do we get? Apparently we get 6 equals a times 4 over 3. Ah, yeah, so this is interesting. So what I did here, guys, see that? What I did was there, I just said, okay, well, I know that b is the log of 4 over 3 with a base of e, but I know that e to the b in the line above was 4 over 3. So this equation here, it's got 6 equals a times e to the b. So why not just substitute e to the b straight from here, rather than what our answer for b is? right, in a log form, just substitute here, and it just makes life so much easier, right? See, a few little tricks, but it makes logs very friendly and exponential. So therefore A is going to be 6 times 3/4. I can see some cancelling there. Yes, it's 18 over 4 or 9 over 2. Okay, I think that's done now. So therefore B was, what did we say it was from over here? It's the log base E of 4 over 3, and A was 9 over 2 for me and you. Woohoo! Now I've got 3 more customers for you, which are, these ones can be pretty mind-boggling. So I've done 3 more examples for you. These ones I'd say are not trivial at all, not trivial, and you can get yourself into a great big mess with these. In fact, I did with this one until I really thought about what I was doing. So you can basically rush in and make a great big mess and end up in algebra no man's land, or you can have another go at it, think very carefully the best way to do it after you realise it's just not going to give up without a fight, this one. And I think what you should do is pause the video and have a go, because that's the way you're going to learn the most. So why don't you go ahead and do that, and I'll wait for you, okay? Right, you're back? Alright, well, how did you go? Did you end up in the algebra abyss? Hope not. I'll show you this nifty little way of doing this, okay? So we've got, that's our equation, we know that much, yes? And we're doing base 2 apparently here, not base E, just base 2, but that doesn't make any difference, it's the same procedure. So let's do our equations first, that's what we need to do. So you substitute 5 and 2 in, you get that. Alright, good, and you substitute 7 and 4 in, you get that. Okay, that's equation 1, we know that. And this one is going to be equation 2. Yes? Now, the question is, what do we do? What do we do with this? Well, you know, it's probably wise for us to use that same trick that we've been doing with the last couple, and that's just to divide one equation by another, because we're going to get rid of the A that way, aren't we? So what about if we divide equation 2 by equation 1? What do we get? Alright, so 4 over 2 is 2. The A over A is just 1, so that knocks out. You've got this thing here, log of 7 minus B base 2 over log of 5 minus B base 2, alright? Now, the question is, guys, what are we supposed to do with this? How are we supposed to extricate this B out of here and figure out what it is? Well, actually, it's rather incredible. Are you ready for this? Alright, stand by, roll the drums. You do this, that's the first thing you do, that's nothing sensational. But what you can then do is you can use, this is a really nice trick, you can use your log laws to make this term here the log of 5 minus b all squared, right? Take that 2 from out the front to put it in there as an exponent of the 5 minus b in brackets term, right? Now, see, look, you can just equate this with this, because if the log of this is equal to the log of this, then obviously this must equal this. Looks simple, but I can tell you, you can get into a great big mess trying to work these kind of things out. So, now what are we going to do now? Well, we have to solve it for b, don't we? Yes. Now it hasn't given up without a fight yet. There's an extra little dramatic bit at the end, okay? So if I multiply that left-hand side bracket out and just express it like that, now I've got to find b. So it looks like I've got a quadratic, doesn't it? Yeah, I got a quadratic. So is that looking correct? Yes. All right. Now watch this. This is a very, very, very big trap coming up. Yes, very nice. We're on a high here. We get b is 6 or b is 3. Now, when you get answers for variables behind log signs, you have to be jolly, jolly careful, because if you have a look at, you've got to test them out to make sure that nothing comes out as a negative behind the log sign. Now, if you look at that b was 3, look up here. Look up here. Now, that's going to be all right. B, this term here would be 5 minus 3, which would be 2. This term here would be 7 minus 3, which would be 4. But what happens if we choose b equals 6, guys? That would be the log of minus 1. Danger, danger, no good. You can't have the log of a negative number. This one would be alright down here. 7 minus 6 is 1. That's alright, but that's not. And they have to both be alright. So that actually proves to us that even though the mathematics works fine, in the context of this b being stuck here behind this log sign, 6 is not going to work. 6 is not going to work. So as I've said down here, log of x with any base is only defined if x is greater than 0, right? So therefore, if you look at equation 1, as I said, then this is not true if b equals 6, because 5 minus 6 is minus 1, and you can't have the log of minus 1. It just doesn't work. Okay? So therefore, we can say hence b equals 3, and b does not equal 6. Does not equal 6. See, now, look, 95+% of students would get that wrong. Can you please be one of the ones that gets it right? Because Wolfman showed you what to do. When you get answers for pronumerals, which you're taking the log of, you must check back after you get your answer to see that nothing is negative behind the log sign. That is the golden rule of making logs friendly. Now, we're going to substitute b back into equation 1 now that we know that b is 3. Equation 1 becomes, what does it become? 2 equals a log 2, and a just drops out without any trouble at all. Okay, so a is, because the log of 2 with a base of 2 is 1. So, yeah, so a is basically 2. How do you like it? Pretty good, hey? So there's your answer. There's your answer. Okay? So, did you learn something? I really hope you did. Okay? So let's do the next one now. Why don't you have a go at this one too by pausing the video and just then coming back when you've got something, because you'll learn much more if you do it that way than if I just show you how to do it. You don't learn anything if I just show you, or at least, you know, you don't learn a lot, but you really do learn if you try first and then you come back and see where you might have had trouble. So, alright, I'll wait for you. Okay, you're back? Alright, the points 3, 10 and 5, 12 lie on the graph of the function with rule y equals a log base e x minus b plus c. Goodness gracious, guys, we've got 3 variables now to solve for. This looks a little bit troublesome, and we've only got 2 points to substitute in. Gracious. But they do give us a third bit of information, that the graph has a vertical asymptote with equation x equals 1. Now that's vital. That's our third clue. That's as good as another point. Find the values of a, b and c, all right? What do you think what did you do? Did you get stuck? Well, there's really no reason to get stuck once you get a little bit familiar with these. So we've got x equals a log base e of x minus b plus c. Now, if the graph has a vertical asymptote at x equals 1, which is normally for a log graph at x equals 0, that's telling us that there's been a translation 1 unit to the right, or in the positive x direction, right? So therefore, if you look in here, you know that this guy has been moved over to the right by 1, so b has to equal 1. Well, that was easy, wasn't it? I told you that third bit of information was a vital clue. So now we're down to 2 unknowns. Well, this should be perfectly doable. So I suggest we just proceed now and substitute our 2 points in. We substitute 3 and 10, we get that. We substitute 5 and 12, what do we get? That, don't we? Yes, we do. Now this time, guys, I'm not going to go dividing one equation by the other, because I've got this extra thing here, this extra c. He's a little bit of a trouble, and that means that, you know, I can't go, if I divide one equation by the other, I just can't go cancelling out the a's. I've got this whole right-hand side to worry about. Okay, so that's a compound term with a plus in the middle on the numerator and the denominator, so that's not going to fall into the ambit of dividing one equation by the other to get the solution. So it's probably better if we morph back into our traditional way of solving these things, and if I basically subtract one equation from the other, this time I'll get rid of c. See? Pardon the pun. Right, so if we subtract 1 from 2, for example, what are we going to get? From 2. So we're going to get 2 equals a log 4 with a base e minus a log 2 with a base e. Well, that's all right. That's fine. So we just got to get a now. So that means it's a... Oh, look at that. Oh, that was a nice little trick, wasn't it? Look at that. That's... So that's basically a log 2 squared minus a log 2 base e, which is, look at that, my goodness. So that's 2a log 2 minus a log, yes I know, it's a good little trick, isn't it? So therefore, what are we going to get? We're just going to get a log 2. Now remember we're trying to get a, so therefore a today is 2 over log of 2 with a base of e. Wasn't that nice? So now what are we going to do now? Substitute for a, back for a into one of those equations. Equation 1 will do, and we get equation 1 gives us that 10 is equal to, now that's our newfound value of a times log 2 plus c. So we're going to get, oh look at that, that's going to cancel out. Oh, how beautiful. So it's so easy. So therefore 10 is equal to 2 plus c, therefore c equals 8. My goodness, that was very, very nice, wasn't it, the way that worked out? So there we are. There's our A, there's our B, and there's our C, lined up like ducks in a row, conquered and taken prisoner by us. Okay, last but not least, over the page. Now, you have a look, you have a go, pause the video, come back. Right, you're back? Okay, how did you go? Well, I think this one here, when I look at it, it's probably fairly similar to the technique we used in the last example. So here's our first line. I've substituted the point minus 2 and 6 in there to get my first equation. That's my first equation. Yes? And here comes my next one. That's f of minus 4 equals that, and that equals 8, and that's my second equation. Now what I've got to do now is, look, I've got two equations, two unknowns. So you have a look, and well, you've already done this, haven't you? So what I'm thinking there is, I know I'm not going to divide one equation by the other. I'm going to do the old subtract one from the other. Yes, but first, before I do that, this little card, this little rabbit out of my mathematical hat, I'm going to call that 2 squared, and then I'm going to put the 2 out the front to make that 2a log 2, which means that that's going to be nicely interacting with this one when I subtract one equation from the other. You see the trick? It's beautiful, isn't it? So that's my equation 2, rewritten in that way. Now, if I then say, therefore, from equation 2, I'm substituting b is equal to this thing, and I'm going to put that into this equation here, and a is going to give up without a fight for us. So substitute that into there. So I get that, and we're going to basically just keep going with that now. Sorry about that phone. And let's solve it, okay? Now you can see how easy that's going to be to solve now because of my little trick up here in calling this log 4 of 2 log 2. Nice little trick. Can you keep that one ready on standby for when you have to get on the attack with these logs? It's nice, isn't it? So look, they're friendly now. See? Now, simplifying, what are we going to get? Yes, do you agree? Good. Now we're just going to divide both sides by minus log 2 base e, and we get that. Yeah, we get that. Isn't that great? Now we're going to substitute back for a into one of those equations. Probably, I don't really mind. We'll do it into that one, 2a. Will that do? Yes, and what do we get? Oh, look at that. This is on the denominator. This is on the numerator. Well, life's good, guys. Yes? So what do we get? We get 4 plus b equals 8, and therefore b equals 4. Isn't that good? How do you feel? Did you get that? Did you get that out? Hope so. If you didn't, hope I've taught you basically a different way of looking at it so that you'll get more confident with time. So there's our summary there. A is this, B is that, and I'm going away now having a nice cup of green tea. And I wish you one too. So, hope you have a wonderful day, and we'll see you next time. Bye.